phase. Probably one of the core elements of audio, yet it is so often misunderstood. Lately, I saw people telling you shouldn't use low-cut filters because it's messing up with the phase, but actually why and what's the problem, or actually how can a low-cut filter solve your problem? Phase flips, why actually it's polarity flip, and on many mixing consoles you see this little phase button which is actually not working on phase but on the polarity. And so between phase, polarity, frequency, time delay, what are all those things doing to your signal? What should you know about phase to use it to your advantage, and how can phase be a problem solver instead of a problem maker? Phase is happening in the acoustics of a place. When the sound bounces back to your wall and come back, then there is comb filtering that is induced by actually time displacement between two signals. So all these things come down to time, phase, polarity. Hello dear audio wizards and fellow music makers. What is phase? To start things easily, let's just take a single sine wave and let's look at the points through the whole curve. The wave is starting, goes up, goes back to zero, goes down and comes back. Okay, so if we move along this waveform through time, we're gonna get through all the different points of that waveform. If we start at the beginning, we are at 0 degrees because phase is expressed in degrees. It's coming back to trigonometry. If we start at 0, we are at 0 degrees of phase. We are at the beginning of the waveform. If we go up to a quarter of the wavelength, we are at 90 degrees. If we go further, we go to 180 degrees, we are back at the 0 point. And this is why there is a first common misconception about phase flip, or actually polarity flip. If we are summing two waveforms that have a difference in time of half of the waveform, 180 degrees, one will go up while the other one will go down. And this is why actually for a single sine wave, moving through 180 degrees of that sine wave through time is creating the same result as a polarity shift, because the two waveforms will now work against each other. Only if the waveform is symmetrical. If the waveform is asymmetrical, then it's not the same either. Polarity is at the same time we are flipping every element of the waveform, while actually a phase shift is moving to another position in that waveform. Phase shift is time related, it's time dependent, while a polarity inversion is time independent. If we have two sine waves summed at the same time, let's say one at 100 Hz and the other one at 200 Hz, to take easy examples, 200 Hz will move twice as fast. So for one given time difference, the phase difference will not be the same for the two waveforms because they don't have the same speed. So if we move through time through one, will not be at the same position for the other one. When you sum two signals that are inverted in polarity, you get a total null. And this is why usually people refer to phase flip. It's a polarity flip. Hey, this is the other me, the video edit checker. I realized I finished this video and I didn't tell you why null tests are so important and why so many people are talking about them and using them. The first main application is to identify the alterations that have happened to any audio signal. For example, you are using a limiter on your audio channel. You are doing this with level matched signals, and then you are flipping the polarity either from the dry signal or from the limited signal. What will remain is the difference between the treated and the untreated signal, hence the artifacts of the treatment. So for example, if you are converting a sound to MP3 and you want to address the impact of the conversion, well, you can then load both the original file and the MP3 converted file and flip the polarity of either of the files. You will hear the alterations the MP3 brought to your signal. And this is something more and more plugin manufacturers are adding to their plugin, is what they call the delta feature. And basically it's just embedding that same thing in their plugin, or you can make it your own with an effect track, putting any given plugin on that chain, flipping the polarity and summing that with a dry signal. And it's a very good practice to start to hear what your tools are doing to any given signal. Here's a very practical application of the polarity flipping that we will use later on. We have operator playing, and this is entering a chain where I have one low cut filter, and I sum this with the, let's say, dry signal, nothing on it. So dry signal, and the one that is filtering the sound with the polarity flip. The polarity flip will flip what is remaining and actually will subtract that from the dry sound, hence creating a low cut filter. So we come from a high cut to a low cut, thanks to the polarity flip summed to the dry signal.